Hello everyone, and welcome to yet another problem from Geeks for Geeks. Today we'll be seeing one of the very standard problem known as finding the length of a loop. We are provided with a linked list, which may not contain a loop, uh, and we are asked to say how many number of nodes are there within a loop. So within this image, you can see there is a loop over here, and within this loop, you can spot there are 4 nodes. So resultant output we can see is 4. So yeah, next is 4. Also there might be no loops in this case of example 2, and here the return output would be 0 because there are no loops. With that in the mind, let's get started. So how would we approach this problem? First of all, we need to find, does the linked list which we provided has loop or not? So if it has, then how many nodes? And once we get the number of nodes, we are good to go. But the two problems over here is how to find out whether a list has loop or not. And the second subsection involves counting the nodes. How to identify. So let's see how we can do this. So we can go ahead, we can iterate this loop, we can iterate the linked list one by one. So if we iterate over here till this point, this point, this point again far, but it will keep on going on and on and on and on because we won't hit null anytime and it will keep on going. So we cannot just go ahead and iterate. We can do either of one thing, that hey, we can go ahead and if we spot 25, let's add 25 into our set. If we saw 14, let's add 14, 19, so on till 45. And if we see that hey, next to 45 is 33 and 33 is somewhere here and we have visited it, it means that hey, it contains a loop. We can do that, but obviously the time complexity would be O of n and space complexity would be O of n in this case. So cool, what does we require here? But do we need that? No, the expected auxiliary space complexity needs to be O of 1, so we'll not go ahead with that. Another one such approach can be of the format like, let's ignore about storing. What do we want it in storing? We wanted to check one node from here which is already visited, and one node which is iterating. So why don't I do one thing, that let's get ahead with one node which would mark the visiting and one node which would iterate on and on and on. And this node can be checked often. Okay, that can work, but how would we remove the possibility of endless loop? Because if we go ahead and check two nodes which are adjacent to one another, will keep on going on and on and on. So like this, first two were 1 2, next would be 2 3, it would be 3 4, and it would go on and on and on. We don't want that, right? So we need to have a difference between them, a delta which will be a reason for visiting to be mapped with stationary, or a slow pointer to be mapped with the fast pointer. So fast and slow. So how do this works? It works very simply that hey, we have a fast pointer. I'll just take this to be here. Initially we have fast pointer over here and slow pointer over here. So next time when the fast pointer iterates, it will go over here and the slow pointer would be here. Notice or note that the fast pointer iterates twice and the slow pointer iterates just once. Next time it will go here, slow will be still here. Next to it, fast, slow. Next is fast, slow would be this. Next would be here is fast and here is slow. And next time when fast iterates over here and slow moves here. And next to next is this, and for slow is this. Hence they move both slow and fast meet at the same point. Then we can say that hey, this linked list contains a loop. Notice slow hasn't even traversed the entire list till the point of 45 and we got to know that hey, this list has a loop or not. So it's quite efficient in that sense because it doesn't take any other space complexity, and yeah, that's nice. But how do we solve the number of nodes within the loop? That's a good question. So for that we'll look further, but till this point let's get down how do we identify whether it's a loop or not. So consider if this question is asked to you within an interview, what would you do? Obviously you'll go ahead and first check whether head is null or not, because validations are super important. Head.next is null or not. So it's okay to have head or head.next null. In that case we just go ahead and return 0 because it doesn't have anything. We'll just check. This is just by the way, this is just nothing but a check for single node, and then we'll go ahead to check whether loop exists or not. So we'll have slow pointer which initially points to head and node fast pointer which also initially points to head. We'll check while that fast pointer is not equal to null or fast.next is not equal to null, because we don't want to end up within the null pointer exception. Why? Because further we'll go ahead and we'll make fast is equal to fast.next. We'll advance by 2 points, and for slow we'll advance just by 1 point. Obviously we'll check if fast equals slow as we did over here in this section where fast and slow were equal, and we return that hey, it contains a loop. So for that, if we saw it has loop, we just go ahead and we break it, and at this point we can say that hey, if fast is not equal to slow, then it does not have loop. Or in other case we can also say that fast or either of this condition is true, then it went over here. So if it does not have loop, number of loop nodes within the loop is 0. Cool. Nice. So going further, now how to calculate the number of nodes within this loop. So you see, we were at this point of meet. Our fast and slow were at this point, slow and fast. What if we take either of the pointer and we move it one by one, counting it 1, 2, 3, 4, 5, 6 times, iterating with this one included. So 1 plus 6, which takes us to 7. So 7 it is. So why don't we do that? So let's take it simple, straightforward, where we have a count. Initially int count is 1 because we are currently within that node, and we iterate one by one a traversing node. So while fast is not equal to slow, and initially we wanted to make it unequal because slow dot next, because fast and slow were equal, that's the reason we ended up over here. We'll just increment the count and we'll say fast is equal to fast dot next. No need to check the end conditions, because if the code control comes over here, we are sure that the linked list contains a loop, and in this case ultimately when the loop is finished, we are sure that count will contain number of nodes within the loop, in this case 7 and in this case 0. So let's compile this to check with test cases, sample test cases. So it works. What about the rest of test cases? Oh, it seems we have had a null pointer exception because we missed the and not or. So let's try to submit this, because here is anding operation and not or. What will happen, because if we take and, you might ask, we might miss one skip and we might go ahead and check the null dot next, because let's suppose if we are here and we need to advance to next, so we'll take next dot next, which is perfectly valid. But what if we are at this position and we wanted to go to 2 positions next? So next of next is not even possible in this condition. So it seems that our solution has been accepted, and this was about how to find the number of nodes within a loop. But can you find what is the starting position of this loop? To know more, click the video on your right, and I'll see you in the next one.